a couple of examples, and we're going to start with all right, let's look at 4p squared over 3p to the negative 5. And then all of this is to the second power. All right, so that's a 2. Okay. So there are multiple ways to go about this, but I'm going to explain what I think is the easiest strategy in terms of, procedure. So we know that this outside exponent is going to apply to everything inside. And when we apply it, we multiply the exponents. So this is actually like 4 to the first power, even though we don't write the 1 there. And again, this is 3 to the first power. So what gets multiplied is the outside exponent to the inside exponent. I like to start with the fraction bar so I don't kind of confuse what goes in the numerator and what goes in the denominator. And so I'm going to apply this outside exponent by multiplying to the inside. So this is 4 to the 1 times 2, or 2, p to the 2 times 2, or 4. And then on the bottom, this is 3 to the second power, again, multiplying the 1 times 2, and p to the negative 5 times 2, or negative 10. Okay, so negative exponent means reciprocal. And so in short, that means any negative exponent on the top will drop to the bottom. Any negative exponent on the bottom, we're going to take to the top. So everything else stays put. So these positive exponents, these terms, these stay put. So this is 4 squared, stays where it is. P to the 4th stays where it is. 3 squared stays on the bottom. But now this p to the negative 10, I bring to the top and make that a positive 10. Okay, so now I have all positive exponents. I just need to now apply the law of exponents, right? So I'm going to go ahead and just rewrite 4 squared as 16. Since I'm multiplying like bases, I add the exponents. So this would be p to the 4 plus 10, or 14. And then on the bottom, we would have that positive 9. Okay, let's take a look at another one. This time, we're going to have that outside exponent is going to be negative. So let's take a look at, okay, so this is x to the negative 2 over 4 x to the negative 4. And then on the outside exponent is negative 3. All right, so let's apply that same strategy. I'm going to start with my fraction bar so I don't confuse levels. And I'm going to multiply. So I have x to the negative 2 times negative 3 is a positive 6. On the bottom, remember, this is really 4 to the positive 1 power. So this becomes 4 to the 1 times negative 3, or negative 3rd power. And then this is x to the negative 4 times negative 3, or positive 12 power. Okay, so now let's rearrange. Remember, positive exponents stay put. So x to the 6 stays in the numerator, and x to the 12 stays in the denominator. But this 4 to the negative 3 comes up, right? So that becomes 4 to the positive 3 in the numerator. Okay, so now remember, in order, my final answer should just have one of each variable represented. So that 4 cubed, that equals 64. We typically write the numbers first, not because it's more accurate that way, it just looks prettier. But now we have, so when we have the x in the numerator and the denominator, this is when we subtract exponents. And the way I think about this is I just think about, where do I have more x's? I have 6 x's on the top and 12 x's on the bottom. So my variable is going to stay on the bottom where we have more of them. So this will be x to the 12 minus 6, or 6th power. Okay, So now let's look at some that are a little bit more involved. All right, so let's take m to the negative 4, n to the negative 3, and p squared. And then this is all going to get divided by m times n to the negative 1. And then this is all taken to the second power. Okay, I'm going to apply the exact same process. Start with the fraction bar, and now we're going to multiply exponents. So this becomes m to the negative 4 times 2, or negative 8, n to the negative 3 times 2, or negative 6, and then p to the 2 times 2, or positive 4. And now same thing on the bottom. So this becomes m, remember there's an understood 1 exponent, so 1 times 2 is 2, and n to the negative 1 times 2 is negative 2. Okay, so now we rearrange. So remember, positive exponents stay put, negative exponents change levels and become positive. So I'm going to write my positive ones down first, okay? So that p to the 4, it doesn't matter where you put it on the fraction bar, but p to the 4 stays where it is, and m squared stays where it is. So now the negative ones are going to move. So I'm going to go in order. M to the negative 8 will come down and become m to the positive 8. N to the negative 6 will come down and become n to the positive 6. And n to the negative 2 goes up and becomes n to the positive 2. Okay, so now let's see what we can combine. Okay, fraction bar. All right, so I see I have the two m's on the bottom, so I'm going to add those exponents. So this is m to the 2 plus 8, or 10. And then I have an n up top and an n on the bottom. It's bottom heavy, right? I have 6 n's on the bottom and 2 up top, so it's going to stay on the bottom, and 6 minus 2 equals 4. And then I have that p to the 4th in the numerator. So we're simplified. One of each variable, all positive exponents. Okay, one more. This time let's make sure we have that outside exponent is negative. Okay, so this is, we have 4, a to the negative 1, b to the 6th, and this is over 3, b to the negative 6, and a to the negative 3. And then this all is to the negative 3 power. Okay. Again, start with my fraction bar. We're going to apply that negative 3 exponent to everything inside, multiplying exponents. So this is, remember, 4 to the positive 1, so this becomes 4 to the 1 times negative 3, or 4 to the negative 3. A to the negative 1 times negative 3 is a to the positive 3. And b to the 6 times negative 3 is b to the negative 18. And then on the bottom, we'll have 3 to the negative 3. We'll have b to the negative 6 times negative 3 is positive 18. And then a to the negative 3 times negative 3 is a positive 9. Okay, so now let's rearrange. Anything with a positive exponent stays put. Anything with a negative exponent is going to change levels. Okay, let's just take this in order since this one has a lot going on. Okay, so I'm going to change colors just to make it easier to track. All right, so we've got 4 to the negative 3, right? So that becomes 4 to the positive 3 on the bottom. A cubed is going to stay where it is. B to the negative 18, that's a negative exponent, so it's going to come down and become b to the positive 18. Now let's tackle the bottom. Okay, so 3 to the negative 3 will come up and become 3 cubed. B to the 18 stays where it is. And a to the 9 stays where it is because it's a positive exponent. Okay? So now I just need to combine what I can combine. Okay, so notice we have the 3 cubed, right? So that's just going to be 27. I'll write that down. So we took care of that. 4 cubed is 64. So I'll write that down. Okay, so now notice I have an a cubed up top and an a to the 9 on the bottom. Since there's more on the bottom, a will stay on the bottom. So 9 minus 3 is 6. And then I have these two b's next to each other. So that will stay on the bottom, and 18 plus 18 is 36. So that is my final answer.